Okay, so this is test 1 review. There are 30 questions I'm going to do here. If something is repeated, then I'm going to skip those questions. Okay, question number 1: determine whether the given source has the potential to create bias in a statistical study. The American Automobile Association (AAA) is a not-for-profit federation of motor clubs that provides automotive and travel services. AAA conducts a survey of its member. Remember, there is a survey done by AAA itself to its member. So I already see the biasness here about their use of public transportation. It's not public; it's a private versus private automobile. So there is a biasness. Okay. So what is the source that potential to create the bias? Let's read the options given here. There does appear to be a potential to create a bias. Yes, there is a bias. So there are two options you have. First one and the second one, which creates a bias. C and D, they say there is no bias. So the answer should be either A or B. So let's read A. There is an incentive to make the result statistically insignificant. No, that we don't know about that. There is an incentive to produce results that are in line with the preferring private automobiles. This is private, so this is the answer. Okay, so yeah, let's go to the next question. Determine whether the sampling method described below appears to be sound or is flawed. So basically they are explaining, given us a sampling method. We need to find out either that is something fairly done or not. So let's read. In a survey of 774 subjects, the following question was posted on a newspaper website. In your view, are nuclear plants safe? The survey subjects were internet users who choose to respond to the question posted on the electronic edition of the newspaper. So remember, it's already voluntary response sampling process. So choose the correct answer. It is flawed because it is not statistically significant. We don't know about that. This is not the right option. It is flawed because it is a census. No, it's not census. It is flawed because it is a voluntary response sample. Yes, that's the right one. Identify what is wrong. So here is another sampling process. We need to find out what is wrong here. The software package StatCrunch coordinated a future optimism survey that included this question: do you expect to be better off than your parents were over their lifetime? StatCrunch users could choose to complete the survey and obtain results. Among 1019 StatCrunch users, so this sampling is from StatCrunch user, 587 said they expected to be better off than their parents. So we need to find out what is wrong. Let's read the options we have given. The order of the question is loaded. No. A large portion of StatCrunch user refused to answer. No. The sample is voluntary response sample. The respondent may not be representative of the larger population. Yes, that's the right one. It's only 1019 StatCrunch user. It's only the StatCrunch user. It's not larger population. Okay. Let's go to the next question here. Determine whether the underlying number is a statistics or a parameter. If something is taken from a whole population, that is called parameter. Otherwise, it's a statistics. Okay. In a study of all, so look at here, it's all. So it's a population. So it should be parameter. Okay. So our answer should be either this one or this one, second or third. And now read. It is found that 50% on a computer. Parameter because the value is a numerical measurement describing a characteristic of a population. Yes. Whenever it's about all, that means it's a parameter. Determine whether the data described below are qualitative or quantitative. Remember, quantitative means number, but at the same time you should be able to play with that number. Play means you should be able to do mathematical operation which should give you the valid answer. So the preferred hands of an experiment's participants. The preferred hands of an experiment's participants, it's not a number, so it's a qualitative. So the answer should be B or C, because both of them have qualitative. A and C, they are quantitative, so they are not right. So let's read B. The data are qualitative because they don't measure or count anything. The data are qualitative because they consist of counts or measurement. B is the right answer. State whether the data described below are discrete or continuous. So number 6. State whether the data described below are discrete or continuous. The number of countries in the world in different years. So in different years it could be specific numbers, so it's a discrete because data can take on any values, on specific values. Okay, so the number of countries could be 5, 10, 100 specific values. The next one, state whether the data described below are discrete or continuous and explain why. The land areas of different countries. So areas, land area could be continuous because the data could be on any interval. So the answer should be either A or B. If you read A, it says specific value. That's not right. It's a continuous because the data can take on any value in an interval. Okay, which of the following is associated with a parameter? So parameter means it's for population, okay, and statistics is for sample. Data that were obtained from an entire population, that's called parameter. That's right. Which of the following would be classified as a categorical data? So it should be so as you can see, amount of rainfall, how many, tree height, hair color, number of suitcase on a plane. So categorical means it's a non-quantitative data. So that's the one requirement. Sometimes data could be number, but that's meaningless. That's just for the different category. In this case, hair color is categorical. So for this problem, you have given data with the frequency. Relative frequency means percentage for each data. So to answer this question, first of all, you need to find out how many data are there by adding all this frequency. And then after that, you have to divide each frequency by total number and multiply that by 100 to get the relative frequency. So here total frequency is 2 plus 12 plus 13 plus 6 plus 1, which is 14, 17, 27, 33, 34. So to find the relative frequency, you just have to divide 2 by 34 and multiply it by 100 to get the relative frequency. So I'm going to use calculator here. The total is 2 plus 12 plus 13 plus 6 plus 1, 25 plus 6, 31, 34. So 2 divided by 34. That's a decimal representation. For the percentage, to get the percentage, you can just multiply it by 100. Okay, so I can just copy this in Excel and then find that information quickly for you, but you can always use the calculator. So to the total data is 34, and we just have to divide each of these data by 34 and times it by 100. That gives us percentage. And now, because we would like to round it to the 2 decimal place, here is the rounding. So it goes to from it is a 2 decimal place. Now if I just highlight it and scroll down, it gives me, what is that? What did I do wrong? Okay, instead of choosing 2, I have to choose this cell, and that gives me answer. Now when I scroll down there, now it's going to use this value 12. Look at here, for the second one, I'm dividing A2, which is 12 by 34, times it by 100. So these are the numbers, relative frequencies. I'm going to type this value here. You can do it using the calculator as well, okay? So 5.88, 5.88. Next one is 35.29, 35.29. Next one is 38.24. Next one is 17.65. Next one is 2.94. So that's the answer. So remember, to find the relative frequency, you just have to add all the frequency and divide each frequency by total and multiply it by 100 and round it to the 2 decimal place here. Let's go to next question. This is our frequency table, and identify the lower class limits. So in this frequency table, lower class limit are 0, 100, 200, 300, 400, 500, 600. So that's what they are asking us: 0, 100, 200, 300, 400, 500 and 600. So if you look at this interval, you can see the lower class limits from the left value. Now upper class limit means the higher value here: 99, 199, 299. So it's a 99, 199, 299, 399, 499, 599 and 699. That's upper limits. Now the next question is identify the class width. To find the class width, we can just subtract the lower class limit of one interval. So if you subtract 0 from 100 or 200, 100 from 200, that gives you the class interval. So if you subtract one lower class limits from next lower class limit, or any upper class limit from next upper class limit, that gives you the class width. In this case it's 100, because 100 minus 0 is 100, 200 minus 100 is 100, and 199 minus 99 is also 100. So if you subtract any number from here to next number, that gives us the class interval. Identify the class midpoints. So the class midpoints, you can see what is the midpoint of 0 to 99. So just 99 minus 0 divide by 2, which is what is that? I'm going to use calculator here, clear it. 99 divided by 2, that's 49.5. 49.5. To get midpoint for next interval, you just have to add this class interval. So 100 plus 49.5, which is 149.5. Just add 100 from the previous midpoints to get the next midpoint. So 249.5, 349.5, 449.5, 549.5 and 649.5. So identify the class boundaries. So class boundaries means any data less than up to 99 goes to the first interval. Any data including 100, after 100 and less or equal to 199 goes to the second. So in between 99 and 100 there should be also, there could be data. So like for example 99.1, 99.2, 99.3. So the boundary would be 99.5 for the first one. Anything greater than 99.5 goes here. That's called boundary. So take the lower limit and then and then upper limit. So lower limit is upper limit from the first class and the lower limit from the second class, 99 and 100. So the midpoint of this value would be the boundary point. So in this case it's a 99.5. Second one, if you go 199.5. Now to find out the rest of the boundaries, you just have to add this class interval. So 199.5, 299.5. These are the boundaries value. 399.5. They separate the data, you know, from one class interval to the another class interval. 699.5, 799 point. Okay, we have to start with the 0. Okay, the class interval. Before this there is nothing, so identify the class interval. So I have to do the same thing here, but I have to start from the 0, and then the next one would be 99.5. The next one would be 199.5. The next one would be 299. Next one 399.5, and keep going. 499.5, 599.5, and 699.5. So here for finding the class boundaries, anything greater than 0 goes to the first interval. You know, the second boundary point will come at 99.5 because that will separate from first class interval to the next class interval. Okay, identify the number of individual included in summary. So that can be found by adding all the frequencies. So 45 plus 2, 47, 91 plus 18 plus 1. So I'm going to use calculator here. So 2 plus 45 plus 91 plus 18 plus 1. So it's 157. That's the total number of frequency. Okay, let's go to the next problem. Problem 12 here. The data is given here. For this data, which is actually 45 commute time, so it represents time in minutes. So in minutes, for a worker of age 16 or older in Chicago, construct a frequency distribution, use a class width of 15 minutes. So if we are using the class width of the 15 minutes, then what happens is, to fill out this table, the next, we know the first lower limit for the first class interval is 0. The class width is 15, so we just have to add 15 to get lower limit for the next class interval. So 30, 45, 60, 75. So here it goes to 0 to 14. And then now to get the upper class limit for the next, you know, class interval, users have to add a class width which is 15. So 14 plus 15 is 29. This is 44. This is 59. This is 74. And this is 74 plus 15 is 89. Now we need to find the frequency. For the frequency we need to use this data, so I'm going to just copy this data in Excel. Where is that? This is my previous one, so I'm going to close this, and this is our data. We can always sort this data, so by going here, go to the data and then sort it. So now it's a sorted data. So we can find the frequency from 0 to 14. So as you can see here, 1 2 3 4 5 data are from 0 to 14, so it's a 5. Now next class interval contains from 15 to 29, so starting 15, 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Okay, it's a 14. Next one from 30 to 44, so start from here, 1 2 3 4 5 6 7 8 9 10 11 12 12. Next one 45 to 59, so count start from here, 1 2 3 4 5 6 7 8 9 9. And then next one starts from 60, 1 2 3 4. And next one starts after 75. There is only one data, which is 1. So remember, altogether there are 45 data, so when you add this frequency it should be 45. 14 plus 5 is 19, plus 12 is 31, plus 9 is 40, 44, 45. Yeah, that's right. So do the data amounts appear to have a normal distribution? So look at here, normal distribution, it starts lower and goes up, and then smoothly goes up. So normal distribution should look like this. So it start lower, up, 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 and then slightly go down, 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 down. So here you can see that it start low, that's good, and then up, and then down. So it is not symmetric, though it started low and then up, and now data, your data looks like this. Symmetric, the normal distribution should be symmetric both sides. It's not symmetric, so the answer is no. So we need to choose which one is the right option here. No, because the frequency start at a maximum. No, that's not right. No, because while the distribution is approximately symmetric, this is not symmetric. No, because while the frequencies start low, proceed to 1 or 2 high frequencies, then decreases to low frequency, the distribution is not symmetric. It's not symmetric. So the answer is D. Examine the data and identify anything appeared to be unique. Select all that apply. So as you can see here, this is the data, and most of the data, they are rounded to either 10 or 15 or 20 or 30, 45. It's a multiple of 5. They are just giving approximate data. So the usually large value of 80 minutes appeared to be an error in recording the data. It's not, we cannot say that. Based on the gaps, there is no gap. The data are presented as a quantitative but are actually categorical. No, that's not right. Most of the data values are rounded to the nearest 5 or 10. That looks right. Okay, so here we have given data here, and we just have to fill out this frequency table. It can be done just by like this. You have to count how many of frequency are there from 20 to 29, 30 to 39, and just fill out these boxes. So I'm going to skip this. It's the same as previous one. Here we need to create a table for cumulative frequency. Cumulative frequency means you have to find out anything less than 30. As you can see, from 20 to 29 there are 25 frequency. But now when you try to fill out the second box here, anything less than 40, that comes everything from which is inside 20 to 29 and 30 to 39. So you have to add to the next frequency as well. So less than 40 means this 25 plus 33. So you just have to add them. So 25 plus 33 is 58, right? Yes, 58. So to fill out the next box, you just have to add 58 plus 13, because anything less than 15 means all three of them. So you have to add all three of them. So 58 plus 13 is 71. Similarly, For the next one, 71 plus 2 is 73. For the next one, it would be 73 plus 4 is 77. For the next one, it's 77 plus 2 is 79. And then finally 79 plus 1 is 80. There should be total 80 data. Okay. Now, for finding the relative frequency, it's very similar to one of the previous problem we did. We need to find out how many numbers for each of this category, and we need to find out the total and then divide number for each of the category by that total. That gives us the decimal number, and then to get the percentage we just have to divide that by 100. I'm going to just copy that in Excel, and so you can see here. So these are the frequency we have given. So let's read the problem first. It says, among fatal plane crashes that occurred during the past 50 years, 566 were due to pilot error, 52 were due to other human error, 584 were due to weather, 65 were due to mechanical problem, 368 were due to sabotage. So these are the different category for the accident, and these are the frequency. We need to find out the relative frequency. Relative frequency can be found by dividing each of these frequency by total number. So we can use the calculator, or I'm going to use sum command for in Excel. I'm going to just add all this frequency. So this is the total number. For finding the relative frequency percentage, you just have to divide this by the total, which is 1635, and multiply this decimal. It gives you the decimal number. For finding the percentage, you just have to multiply this decimal by 100, and that gives you the percentage. So I'm just going to copy everything like that and then do the same operation. So this is the the feature I can use in Excel, which is very easy to find out all the calculation. So now we want our answer in one decimal place, so I can just use this one decimal thing. So it's going to just do it for me, and I'm going to just scroll down, and then these are the relative frequencies in percentage. So 34.6, that's for the pilot error, 34.6. So next one is 3.2, next one is 35.7, next one is 4%, 0.0, and next one is 22.5. Okay, so what is the most serious threat to aviation safety? As you can see that the most one is 35.7, which is the weather. So weather is the most serious threat. Okay, so let's go to the next problem. Class width is found by, remember, if you go to the previous problem, we can find the class width by subtracting one of the lower limit from the next lower limit. For example, if you take the lower limit for from here, for the first class interval, which is 0, and then lower limit from the second class interval, which is 100, the difference between them is 100. So that's how we can find the class width. We can do the same thing by subtracting the upper class limit from the next upper class limit. Okay, so class width is found by subtracting a lower class limit from the next consecutive lower class limit. Yes, that is right. This is the histogram we have given, and then the histogram always represents the frequency. This number, vertical number, that they represent frequency. If you add all this frequency, that gives you the total number. So in this problem, the histogram to the right represents the weight in pounds of a member of certain high school programming team. So 120 pounds there are 2, 140 pounds there are 4, 160 pounds 0, nothing, 180 pounds there is 1, 200 pounds there are 5. So if you add all this frequency, you are going to get total team members. So 2 plus 4, 6 plus 1, 7 plus 5, 12 plus 2, 14 plus 3, 17. So you just have to add all the frequencies. Now, so the data we have given here, and there is a frequency table. We just have to find out the right histogram for this frequency table. So from 0 to 14, so first of all we need to choose the frequency table with the width 0 to 15, 15 to 30. Here for the first one, A, the class interval you can see is 0 to 10, so this is not right. So right one should be B, C or D. From 0 to 14 there is 5, so if you check B, this is less than 5, so B is not the right answer. If you check C, that's 5, that's right. D is also 5. Let's go to the next interval from 15 to 29, 14. But if you check C, from 15 to 29, it's not 14. So the answer is D. Okay. So by looking this histogram, if you look at the histogram, it's not normally distributed. It goes up and then down, so it's skewed, right? Skewed. So the histogram it does not appear symmetric, has a longer right tail. So the distribution of the data is skewed to the right. The histogram does not appear to be graph of data from population with the normal distribution. Normal distribution means the graph should look like this. Okay, for the normal distribution your histogram should be look like this, but here it's not the case. One more time, this is also about histogram, so this is very similar problem like previous one, so I'm going to skip it, go to the next problem. We need to use the data here and then construct a stem plot. A stem plot means whenever you have two digits data, you put the left one on this first column and then right one on the second column. So if I copy this data here in StatCrunch or in Excel, and the good thing about StatCrunch or Excel is I can sort this data. So if you use the StatCrunch, you go data and then there is a sort, and here we are sorting the first column, variable 1, and we can just compute it, and now it's sorted data. So now if you try to create the stem plot, on the left side there should be 3, on the right side there should be 4. So 3, 4, yes, first one looks 3, 4, and then 4, 0, 4, 2. Instead of writing 4, 0 and 4, 2 separately, we write 4, 0 and 2. But here in the first one it's a 40, 42, 44, 44, 50, 45. That's not the right one. So let's go to the next one. 4, 0, 40, 42, 46. This is also not right. The only right option now we have is C, because that means 34, 40, 42, 50, 50, 50, 50, 56, and that's the right one. Now the values closest to the middle are, so if you go back to that StatCrunch here, the middle value means there are 20 data, so the middle value should be data number 10 and 11, which is 62 and 64. So 62 and 64. So for this one, we have given the data, we have to find out mean, median, mode, mid-range, and then we have to answer the question given. So first of all, let's copy the data in you can copy this in Excel, because it will be easier for me to use Excel, because we have to add the data for finding the mean. First of all, I'm going to sort this data because we are also looking for median. So the data, go to the data and sort it. Now it's sorted: 20, 24, 23, 31, 53, 58. For finding the mean, we have to add this data. For finding the mean is, first of all, find out the sum of all this data, which is and then divide it by total number of data. Here we have 11 data, so I'm going to divide it by 11. So that's the mean, 54.27273, but we need to round it to the one decimal place. So I can just use where is that? Go home and use this one. So when you do the rounding, it's 54.3. 54.3. That's the mean. Median is the middle number. So here you can see there are 11 data, so the middle number would be the data at 6th position. That's the middle number. So that's 58. Mode means most repeated data. So 20, 22, 23, 31, 53, 58, 69, 70, 73, 79, 99. So nothing is repeated. If there is no data repeated, there is no mode. And mid-range, it's mid-range is the highest data plus lowest data divided by 2. That's the mid-range. So mid-range, check the definition of the mid-range. It should be sum of the highest and the lowest divided by 2. That's 59.5. 59.5. Okay, so to answer this question, first of all, keep in mind these are the data for Jersey number. Actually, those number does not represent any value, statistical value, because Jersey number, instead of putting the name, we are just using the number. So whenever we use this type of data, there is no statistical, these values are meaningless. So what do the result tell us? Since only 11 of the Jersey number were in the sample, the statistics cannot give any meaningful result. No, that's not right. The Jersey number are nominal data and they do not measure or count anything. This is the right option. Sometime we might find our statistics, but sometime based on the data, that might not be so meaningful. So that is the case here in this Jersey number. Here listed below are pulse rate, beats per minute from sample of adult males and females. Find the mean and median, each of the two sample, and then compare the two sets of the results. So remember, mean and median, we can do very same thing like we did before. First of all, let's open the data in Excel, and then for finding the mean, it's just adding this data and dividing it by total number. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 data. For the median, you have to sort this data, okay? And while sorting, you have to keep in mind, let's say sort where is that, from A to Z. Okay, sort it from here. So it's only sorted the first column, okay? And now if you sort the second column, it's not, it's going to, it's a different thing for the first column now. So you have to do it individually. If you are using Excel for finding the median and sorting the data, you have to do it individually. So I'm going to sort it first column. For finding the mean, it's easy, which is sum of the data from here to here. I'm adding them and dividing it by total number of data, which is 15. And I'm doing the same thing here. I can just scroll it and it will give me, look at here, sum from B2 to B16 and divided by 15. So these are the mean. 64.4, 64.4 for the male, and for the female it's 80.80. 80.8. What is that? 80.8. So that's the mean. For the median, you have to do it individually, as I mentioned earlier, because first column is already sorted and there are 15 data. So the median would be a middle number, which is number 8. 1, where is that? 1, 2, 3, 4, 5, 6, 7, 8, which is 63. And I'm going to do the same thing for the second one. The second column is not sorted, so I'm going to sort this. And now I'm going to find out the data at 8th position. 1, 2, 2, 3, 4, 5, 6, 7, 8, which is 84. Okay, so now as you can see here, mean and median, both of these data for the female, they are higher than for the male. So compare the result. The mean and median for females are both lower. No, that's not right. The mean and median for males are both lower than mean and median for females. That is the right one. Does there appear to be a difference? There does not appear to be any difference. The pulse rate for males appear to be higher than pulse rate of females. Since the sample size is small, no meaningful information can be gained from analyzing the data. The pulse rate for females appear to be higher than pulse rate for the males. That is the right option for sure, we can say. That's why we're going to choose that one. Okay. Now, this problem will help you to calculate your grade for the course. Depending on, different category of the assignments we do in class, you can calculate your grade. So in this problem, a student's score grade is based on one midterm that counts as 10%. So whenever you try to, let's say there are different category, midterm 10%. Okay, and next category is what is that? Next category is class project. Class project, that is also 10%. Next category is homework, that is 30%. And then final exam, that is 50%. Now these are the weights of this different type of assignment. And now the points that student got, his midterm score is 80. That's the points. And the class project is 93. And the homework is 86. And then final exam is 71. For finding the total grade, you have to multiply this individual grade with their weight. These are the weights. So 80 times 10%. And then similarly 93 times 10%, 86 times 30%, 71 times 50%. So I can do the same thing by scrolling here. So these are the weights in different category that a student got. To find the total, you have to add them all. So just add. I'm using sum command here. So eventually he got 78.6% in the course. So his overall final score is 78.6. Okay, so now for A, B, C, D, you can see here anything less than 80 is C. Assume that mean of 90 or above is A, mean of 80 but less than 90 is B, and so on. So 78.6 is less than 80, so that should be C. Okay, so that's how you can calculate your course grade. Next problem. Below are the jersey number. One more time, these are the jersey number. So whatever information you are going to find statistical, they are actually meaningless. Okay, but we are just trying to find this range, variance, and standard deviation. So range means it's data from highest value to the lowest value. And so I'm going to copy this, and here you go. So the range, it's highest to lowest. So I'm going to sort this data, go to the data and do the sorting. Now it's sorted. Range equal highest minus lowest, which is in this case 84. Okay, for finding the standard deviation can be found by using formula. If you have data, you have to write down the data here. You have to find the mean of that data, and in the second column you have to find the difference between the data and then mean. Third column, you have to find the square of that difference, and finally you have to add this, you know, this what is this called, this difference, and then you have to divide this by n minus 1 if you are using a sample, and divide it by n if you are using a population. Here jersey number, it's randomly selected from a football team, so that means it's a sample, so we are going to divide it by n minus 1. And then the standard deviation is square root of this value, that's the standard deviation. And variance is, you know, square of the standard deviation. So basically this is the variance. So I'm going to calculate this value here in Excel. So first of all, for finding the, so let me just copy this data somewhere here, and I'm going to name this as X. That's my data. I need the second column, which is X minus mean. I need the third column, which is the square of this previous column, and then finally I have to add this. So first of all, find out the mean for this data. Okay, find out the mean for this data. So what is that? Okay, no, Excel. Okay, so we need to find the mean of this data. So mean is sum of the data, which is sum of this data from here up to here, and divided by total number of data. As you can see, there are 11 data, so you just divide it by 11. So now the mean is 54.72727. So we need to subtract mean from the data. So I'm going to just use equal sign. I select the data minus 54.72727. So that's the difference, and I'm going to do the same thing for all data. And now to square this value, I just have to select the data here and use the square. So that's the square. I'm going to scroll down here, and finally, if you can see here, after finding this square, we have to add this data. So for addition, you can just use that sum command from here up to here. So that's addition. And now finally we have to divide this by n minus 1. In this case there are 11 data, so n minus 1 means 10. And then we have to take the square root of this data, which is power 0.5. So that is our standard deviation. If we would like to round it to the one decimal place, that would be 24.2. Okay, so variance is, this one is the variance, okay, without taking the, or the square of the standard deviation is the variance, so which is 584.62. So that means it's 584.6. That's how we can use this Excel to calculate the standard deviation very easily. So now let's go here. What do the result tell us? One more time, Jersey number are nominal data that are just replacement for names, so the resulting statistics are meaningless. So that's, though we found so many different information about the data like mean and standard deviation and range and sample variance, but it's meaningless for the Jersey number. Let's go to the next problem. Okay, a group of adult males has foot length with a mean of 27.25 centimeter and a standard deviation of 1.24 centimeter. Use the range rule of thumb for identifying significant values to identify the limit separating values that are significantly low or significantly high. Is the adult male foot length 30.0 centimeters significantly low or significantly high? So remember, anything data value, anything lower than 2 standard deviation is significantly low. So here is the mean, anything mean minus 2 standard deviation, anything lower than this value is significantly low, anything more than this standard deviation is significantly high. So significantly low values are, to find that thing we need to find mean minus 2 times standard deviation. So I'm going to use a calculator here. So in our case the mean is 27.25 minus, use the parentheses, 2 times the standard deviation, which is 1.24, close the parentheses. That gives you 24.77. Anything less than 24.77 has significantly low value. So 24.77, but you need to do not round it. So 24.77, no rounding, always read the instruction. So significantly high values, one more time, anything greater than mean plus 2 times standard deviation has a significantly high value. So we are going to do the same thing, but this time it's a 27.25 plus 2 times 1.24. So anything greater than 29.73, any values, it's a significantly high values. Okay, so now, is the adult male foot length 30 centimeters significantly low? No, it's not. It's significantly high because it's greater than 29.73. So the options here, we can say the adult male foot length of 30 centimeters is significantly high because it's greater than 29.73. It's greater than 29.73. Let's go to the next question. In this question we need to find out, it's about the G-score. So G-score can be found, remember G-score can be found for the sample. It's a data minus mean over standard deviation. That's for the sample, and same thing for the population. So that's the G-score. So use the G-score to compare the given values. Based on the sample data, newborn males have weights with a mean of 3,291.2 gram and a standard deviation of 781.8 gram. Newborn females have weight with the mean of this and a standard deviation this. Who has the weight that is more extreme relative to the group from which they came? So that depends on the G-score. A male who weighs 1500 gram or female who weighs 1500 gram. So since the G-score for the male is, so find out the G-score for the male. In this case, it's you need to use this formula. So for the male, the data is 1500 minus average is 3291.2 divided by the standard deviation, which is 781.8. So calculate this value. So I'm going to use this thing. I'm going to use parentheses 1500 minus 3291.2 divided by 781.8. 8. Enter. So the G-score is negative 2.29 for the male. So round it to the 2 decimal places. So negative 2.29. Negative 2.29. And G-score for the female, we can use the same formula, and this time G-score for the female is, it's again 1500 minus the average is 3058.7 for the female, and divided by the standard deviation, which is 579.5. So calculate this value using a calculator here. That gives me 1500 minus 3058.7 divided by 579.5. The G-score for the female is negative 2.69. Negative 2.69. So the G-score, the male has the weight that is more extreme. No, so anything which is less than 2, so you can see that it's a negative 2.69 has more extreme value, so the female has the weight that is more extreme. Anything go back to this problem. So because the G-score for the female has more than G-score for the male, in the more extreme side, anything less than negative 2 is more significantly low extreme value. So because of that, the female has a weight that which is more extreme. Let's go to the next problem. Use the data given here. This is the data we have, and we need to find out the percentile corresponding to 1.11. To find out the percentile, first of all, we need to find out the position of this this data. So percentile can be found. There is a formula. The percentile for any data, percentile for any data equal number of values less than that data over total number of data times 100. So I think this is the right formula, otherwise I can just check just by giving the wrong answer here. It gives me the formula: number of values less than the data divided by total number of values times 100. Total number of values times 100. Yeah, so that's right. So by using this formula, we can find out the percentile. So in this particular problem, first of all, we need to find out the position of this data. So that's why we have to copy this data in StatCrunch or Excel, and then we can sort this data sorting. First column, we are sorting it from lower to higher. So we need to find out the position of the data 1.11. So here is the position 1.11, which is 23, and below 23 there are 22 data. So the answer would be 22 divided by total number of data. As you can see here, if you go down, you can find out the total number of data. There are 50 data, so divide by 50 times 100, which is 44. The percentile of this data is 44. Okay. For finding the percentile, actual percentile P60, 60% P60, you need to find the locator first. Locator can be found by using this formula. Locator is, let's say you want to find out the PK, percentile PK, then locator can be found K over, I think it's 100 times the total number of data. I'm just going to check the formula, okay? Just by giving a wrong answer, it gives me the formula. Yes, K over 100 times the total number of data. K over 100 times total number of data. Let me just correct my answer. K over 100 times total number of data. Yeah, that's right. So percentile can be found by using this formula. In this case, it's 60 divided by 100 times the total number of data. So the total number of data, if you just copy this data in statcrons and then sort it. You can always sort the data. This first column, I'm sorting this. You can always use Excel or statcrons to sort the data. So there are, how many data are there? 50. So it's a 50. So 230. So the locator is 30. If locator value is whole number, we're going to find the mean of the data at 30 position and 31 position. So that means we go here at 30 position, the data value is 1.19. At 31 position, the data value is 1.21. So we are just going to add these two numbers and divide it by 2, which would be 1.2. So P60 is 1.2. So 60% of the data are less than 1.2. That's the meaning of percentile. Number 29, a successful basketball player has a height of 6 feet 10 inches, which is 208 centimeter. Based on statistics from dataset, his height converts to the G-score of 4.81. How many standard deviation is his height above the mean? Remember, the G-score means it's the difference between the data valued from the mean divided by the standard deviation. So G-score equal difference between the data and then mean divided by standard deviation. So if you just multiply both sides by standard deviation, so the difference between the data from the mean is G-score times standard deviation. So to answer this question, you just have to say, hey, this is G-score times standard deviation, which is 4.81. 4.81 G-score is given standard deviation. The last problem, researcher measured the data speeds for a particular smartphone carrier at 50 airports. The highest speed measure was 75.9 Mbps. The complete list of 50 data speed has a mean of 17.71 Mbps and standard deviation is 33.09 Mbps. Now we're going to answer this question. The difference, what is the difference between carrier highest speed and 50 data speed? So the highest speed is 75.9, the mean is 17.71, so we can use a calculator. So it's 75.9 minus 17.71. That's the difference, which is 58.9. Do not round it, so 58.9, 58.9, 19, not 9 only, 19. So that's our difference. How many standard deviation is that? The difference found in part A. So how many standard deviation is this difference? So to find out this difference, you have to divide this by the standard deviation for finding the how many standard deviation. In this case, the standard deviation is given, which is 33.09. So just divide this 58.19 by the standard deviation, which is 33.09, and that is 1.75 is standard deviation. So if you round it to the two decimal places, it's a 1.76 standard deviation. 1.76 standard deviation. Just divide the difference by the standard deviation, and that tells you how many times. So what is the G-score? Actually, whatever we found here by dividing this, the difference by standard deviation, that is the G-score. So G-score is 1.76. 1.76. And the carrier's highest data speed is, because the G-score is 1.76, which is less than 2, it's insignificant, not significant. Something in between -2 to +2 G-score, it doesn't have significant value. So that's number 30.